In this session, we are going to discuss approximations, which is a very important section in the quantitative aptitude part of bank exams. So let's get started with this session on approximations. Approximation consists of various parts, right? In this session, we are going to look at how to find out approximate square roots and approximate cube roots, because sometimes we find that a 1-mark question is given on approximate square root or approximate cube root. Also, in the actual speed math session, you have seen that we have learned how to find out the cube root and square root of perfect cubes and perfect squares respectively. But then to find out the cube root or square root of imperfect cubes and imperfect squares, you need to follow an approximate method. So we are going to look at those methods first, and then we'll understand how to approach towards solving a question on approximations. Basically, how do you do a approximate multiplication? What are the do's and don'ts? Or I should say, what are the things which you must not do while following approximations or while doing approximate calculations? So let's first start with finding out approximate square root. How do you find out an approximate square root of the given number? Well, you are already aware of how to find out square root of a number. Yes or no? We have very well learned this in the speed maths video, how to get the square root of a given number. It is a 3-step process and it would take about what, 4 to 5 seconds maximum, right? Now in this session, we'll look at how to find out approximate square root, right? For example, if the given number is an imperfect square, then how do you calculate the square root of that number? Obviously, we have to calculate an approximate square root. So how do we do that, right? So let's look at finding out approximate square roots.
Having understood what approximation is all about, let's look at the first question from this topic of approximations. So as you can see, the question here is find the approximate value of square root of 8650. And the options given are 84, 22, 17, 31 and 93. So basically it's all about finding out the square root of 8650. Remember, approximate square root of 8650. All right, and also note that approximate square root and approximate cube root are two of the most important concepts from the topic of approximations. So how do we do this? Now in the topic of simplifications, we have already learned how to find out or how to calculate the square root of a given number, right? There is a simple 3-step process which can be applied to arrive at the answer. But remember, that method doesn't work if the number is not a perfect square. And if you closely observe, the number 8650 here is not a perfect square. Well, one simple way to identify that is that this number ends with only 1 0, right? There's only 1 0 here, which means there are odd number of zeros. Note that a perfect square will always have even number of zeros at the end, right? It can have 2 zeros, 4 zeros, 6 zeros, 8 zeros, 16 zeros, but it cannot have an odd number of zeros like only 1 0 or only 3 zeros or 15 zeros, right? So the number here 8650 is not a perfect square. And more than that, anyway, the question here is given under approximations. So we got to find out the approximate square root for the value 8650. So the method that we had learned in simplifications will not be applicable here. So how do we do this? Now, if you closely observe, the options here are 84, 22, 17, 31 and 93. Remember guys, in the topic of approximations, in my view, more than the question, what is important is the options, right? If the options are very closely spaced out, if the values given here are very close to each other, then we got to do a very precise calculation. But if the options or the values given in the options are not very close to each other, then we can do an approximate answer, right? And the amount of approximation that we do would also depend on the options here. So very clearly, what matters in case of approximations is the options more than the question. All right. Now, if you observe options 84, 22, 17, 31, 93 are not really close to each other. So I can do a rough calculation or a very approximate calculation to arrive at the answer. Simple understanding is, let's look at 90 squared. What is 90 squared? 90 squared we all know is 8100, right? Or conversely, we can say the square root of 8100 is equal to 90. Right, 8100 you all know is a perfect square. So square root of 8100 is 90. Now if you look at the number given here, it is 8650. It is more than 8100, right? The number given in the question here, 8650, is more than 8100. So it's obvious that the square root of 8650 will be more than 90, right? As the value increases, the square root also increases. So since 8650 is more than 8100, answer has to be more than 90. Now look at the options. 84 is less than 90, 22 less than 90, 17 less than 90, 31 is also less than 90. So first 4 options are simply eliminated based on the simple fact that answer has to be greater than 90. right? This question mark here has to be greater than 90. The only option available which is greater than 90 here is option 5, 93. So I can simply mark 93 as the answer, right? Now remember, this is possible here because the options are not spaced out close to each other. But suppose if the options are really close, then what do we do? Like for example, let's say the given options are 95, 91, 97, right? Or 98, and then one of the options is 93. Then what do you do? Right? Then how do we arrive at the answer? Because now the technique that we have applied fails in this case. All we know here is the answer has to be more than 90. All the given options 95, 91, 97, 98 and 93 are all more than 90. Hence this technique cannot be applied. But remember, wherever possible, try and apply this process of elimination based on the range of the answer and try to get the right answer here. So let's look at the real process which will help you find out approximate square root. Now again, that method here is really simple. Practicing a couple of examples would help you clearly understand that very properly, and also you can apply it in the exam. So I think what I will do is, instead of directly taking 8650 as the question, let's start with a simpler value. Like for example, let's say we have to find out the square root of 6000, right? Or strictly speaking, the approximate square root of 6000. Again, note that 6000 is not a perfect square. Why? It has got 3 zeros, odd number of zeros. It cannot be a perfect square. All right. Anyway, so we have to find out the approximate square root of 6000. How do we do this? Now, it all depends on the nearest square root that you can find out. The nearest perfect square that you can find out to 6000, or the nearest square root that you can find out for a number which is close to 6000. Like for example, if you look at perfect squares, right? I mean 10 square is 100, 20 squared is 400, 30 squared is 900, 40 squared is 1600, 50 squared is 2500, 60 squared is 3600, and then comes 70 squared. 70 squared is 4900, 80 squared is 6400. You're getting it. 70 squared is equal to 4900 and 80 squared is equal to 6400. Or in other terms, I can say square root of 4900 is equal to 70, and square root of 6400 is equal to 80. Now if you observe closely, the value given here 6000 lies in between 4900 and 6400. Yes or no? 6000 is between 4900 and 6400. So answer has to be between 70 and 80. So that is for sure. The answer here should be between 70 and 80. The correct answer will be in the range of 70 to 80. Now this is what again you need to check first. Look at the options. If the options given to us, all the 4 or 5 options given to us, if only one of those are in the range of 70 to 80, we can simply take as the correct answer. Right? That can be taken as the correct answer. Like what we had done in the original question, right? Only one answer was more than 90, and that helped us mark it as the correct answer. But if all the options are in the same range, or if multiple options are in the range of 70 to 80, then what do we do? Right? So remember, always the first step is to look at the options. Look at the options and try to eliminate the wrong ones. Right? Now, what happens if all the options are between 70 to 80? What do we do? The process is as follows. Let's consider 4900. We know that square root of 4900 is 70. So square root of 6000, which is the question mark that we have to find out here, should be more than 70. It should be 70 plus something. Yes or no? We are required to find out what comes in place of question mark here. I very well know that square root of 4900 is 70. This number here is more than 4900. So answer has to be more than 70. So 70 plus something. 70 plus some value. Now how do we decide what that value is? 70 plus what? Simple. What you have to do here is try to get the difference between the value given in the question and the value that we have considered here. What is the value given in the question? 6000. What is the value given here? 4900. What is the difference between these two values? 1100. Basically 6000 is 1100 more than 4900. 6000 is 1100 more than 4900. Yes or no? 6000 difference, or 6000 minus 4900 is 1100. So what do? We know that answer should be more than 70. 70 plus something. That something is actually 1100. The difference between the given value and the value that we have considered in getting the first term here, divided by this 1100 difference, divided by twice of whatever we have considered in the first step. Twice of whatever we have taken in the first step. 2 times of 70. As simple as that. Approximate square root of 6000 is going to be 70 plus 1100 divided by 2 into 70. Let's relook at the process once, right? What is 70? 6000 is very close to 4900, or not very close, but close to 4900. And why are we considering 4,900? Why not 5,000? Because I know that 4,900 is a perfect square, right? If I know a better perfect square, which I mean, if I know a closer perfect square to 6,000, I can consider that as well, right? Here I would like to go with 70. 4,900 under root is equal to 70. So 70 plus something. Why are we adding here? Because the answer is going to be more than 70. So 70 plus. What is this 1100? This 1100 is the difference between 6,000 and 4,900. The given value and the value considered in the first step. We get 1100 is the difference. This should be divided by 2 times of 70. Always twice of 70. What is 70? 70 is the number that we have taken in the first step. Now what is 2 into 70? 140. 1100 by 140. Or 110 by 14, whichever you take it. 1100 by 140. Now again, if you use your various techniques learned in speed math, 1100 by 140 can be approximately taken as 8 times, right? It is approximately 8 times, because 140 into 8 should be 1120, right? 140 into 8 is 1120. This is very close to 1120, right? So I can say approximately 8. So basically the answer is going to be 70 plus 8, 78. So the approximate square root of 6,000 is 78. Approximate square root of 6,000 is 78, right? In the first step, you knew that answer should be between 70 and 80. And now we have, concluded that answer has to be 78. 70 plus 8, right? Approximately 78. Approximately 78. And obviously, among the given options, only one value will be close to 78. So that can be taken as a correct answer. If you want, you can also find out the square of 78 to see if it is really close to 6,000 or not. Yes or no? If the approximate square root of 6,000 is 78, the square of 78 should be approximately close to 6,000. So square of 78 can also be calculated. Like for example, find out 78 square. We have discussed this in speed math, right? How to find out square of a number? 78 square. 78 squared can be taken as 50 plus 28, right? So 2,500 plus 2,800, 5,300 plus 28 squared is 74. So 6,084. 6,084. Yes, this is going to be 6,084. This thing that we have done just now is nothing but finding out square of a number, which was discussed in speed math. So you see 78 square is 6,084. Is it not close to 6,000? Yes. So this is how you can simply use this method to find out the square root, approximate square root of a given number. Now, there may be a question in your mind. Why did we consider 4,900? Why not 6,400? Well, you can take 6,400 as well. Let's do that now. Let's consider. See, in this first method, we have considered 4,900 as the base. Let's now look at 6,400 as the base. Base meaning the value that we want to keep in consideration. Now, that way, if you see, 6,000 is actually much closer to 6,400 when compared to 4,900. So the answer that we are going to get in this method should be much closer to the correct answer, right? 78 is the approximate answer, but we may get a better answer when it comes to 6,400 because it is very close to 6,000, right? So what do? The same process has to be followed. It's just that instead of plus, we need to take minus here. Why is it so? See, the given value is 6,000. The value that we are considering is 6,400. So basically the understanding is, I know that 6,400 under root or the square root of 6,400 is 80. Since the given number is less than 6,400, answer has to be less than 80. So 80 minus something. 80 minus something. Now how do we find out what is that minus something? What is that something? Simple. The value is 6,000 in the question and the value that we have considered is 6,400. What's the difference between these two? 400. Like what we had in the earlier step, right? Take the difference between the two values, 6,000 and 6,400. It is equal to 400, right? 400. Don't worry about plus or minus, right? It should be taken as only the magnitude is important. 400 is in the numerator. What comes in the denominator? Twice of what? Twice of 80. 2 times of 80. 2 times of 80. So 400 divided by 2 into 80. Right? Now 2 into 80 is 160. 400 by 160 will be exactly 2.5. This is exactly 2.5. So 80 minus 2.5. 80 minus 2.5. 77.5 is the answer according to 6,400 is the base. 77.5 or 78. Both are close to each other. It all depends on the options, right? Remember, in case of approximations, when we are dealing with questions from approximations, we are not trying to find out the right answer. We are trying to find out the best answer. Like in this first question itself, the original question itself, 8650, the best answer is 93. 93 need not be the exact answer, right? It is the best answer. So from the given options, choose the best one. Whichever is closer to 78, 77.5, that can be considered as a final answer. So this is how we find out approximate square root for a given number, right? Approximate square root for a given number. All right. Now, if you again have a question in your mind that why have we taken the range as 70 to 80? Is it always a rule that 70 to 80 has to be considered? No. You can take up any value which is as close as possible to 6000. Like for example, we can also deal with 75 square, like a number between 70 and 80. Right? What is 75 squared? Let's look at 75 squared. Try with that, right? 75 squared. What is 75 squared? Now we have discussed how to find out square of a number that ends in 5. 75 squared will be 7 8 56, right? 5625. 5625. Now if you observe, 5625 is also closer to 6000. 5625 is a perfect square in the first place and it is close to 6000. So if I consider 75 square as the base or 75 as the base, what do? I know that the given value 6000 is more than 5625. So answer should be more than 75. So question mark will be equal to 75 plus something. 75 plus something. Plus what? The difference between 6000 and 5625. So I can say 6000 minus 5625 divided by 2 times of 75. 2 times of 75. What will this be? See, 6000 minus 5625 is 375. Right? This is 375. 375 divided by 375 divided by 2 into 75. 75 here goes 5 times. 5 by 2. 5 by 2 is 2.5. 5 by 2 is 2.5. So overall answer will be 75 plus 2.5, 77.5. The same answer that we had got with respect to 6400. Right? Here also we got 77.5. This also is giving us 77.5. See, basically understand 6000 is in the middle of 5625 and 6400. The distance of 6000 from 6400 is 400. The distance of 6000 from 5625 is also nearly 400, 375. So because the distance is almost the same, the resulting answer is also almost the same, 77.5 and 77.5. So closer the value that we consider, better the answer we get, right? So if you ask me, is the answer 78 or 77.5, which is the better answer? 77.5 is a better answer. Why am I saying that 77.5 is the better answer? Because the number that we had considered when it comes to 77.5 was much closer to 6000 when compared to 4900. Right, so this is how we can always work out and find out the square root, approximate square root of a given number. Let us now take up the real question, the original question. The original question was finding out the square root of 8650, 8650. Of course, from the given options, we know that the answer should be 93, but we change the options, right? What if the options are 95, 91, 97, 98 and 93? In this case, how do we know what the correct answer is? What do we do? The same process. See, 8650 is the given value, 8650, square root of 8650. I know that 8650 is between 8100 and 10,000. Now, why are we taking 8100 and 10,000? Because both of these are perfect squares. 8100 is 90, square root of 8100 is 90, square root of 10,000 is 100. Let's say square root of 8650 is question mark. Now, this question mark lies between 90 and 100. The answer here lies between 90 and 100, right? Lies between 90 and 100. So look at the options. Unfortunately, all the options are between 90 and 100, so can't really do anything, right? Okay, one more observation which can help us eliminate some of the options is look at what value is 8650 closer to. Is 8650 closer to 8100 or closer to 10,000? It is closer to 8100, right? See, the difference between 8100 and 8650 is only 550, but the difference between 8650 and 10,000 is almost 1400 or 1350 to be precise. Since the difference here is less, it is closer to 8100, which means answer question mark should be closer to 90. Answer has to be closer to 90. It should not be closer to 100. So that way you can eliminate some options. Like for example, 97 is closer to 100. It's not closer to 90, right? Eliminated. 98 is also closer to 100. Are you getting the point? What we are trying to now figure out is, will the answer be closer to 90 or 100? We have understood that answer will be closer to 90 because the given value is closer to 8100. Since the answer is closer to 90, some of the options can be eliminated. 97 can be eliminated because 97 is closer to 100 when compared to 90. 98 is also closer to 100 when compared to 90. 95 is exactly between 90 and 100, so can't really say anything about it. 91 and 93 both are closer to 91 and 93 both are closer to 90. Yeah. So this way again you see some options have got eliminated. Of course, we need to do the next steps to find out the final answer, but elimination works. Now what do? Find out the actual answer. Same process. Let's consider 8100. So square root of 8100 is 90. I know that question mark should be more than 90. Question mark, you can see, right? It is greater than 90. Question mark is greater than 90. So 90 plus something. What is that something? The difference between 8650 and 8100. Difference between 8650 and 8100 is how much? 550. Yes or no? 8650 minus 8100, 550. Divide by 2 into 90. Divide by 2 into 90. Done. Now, 90 into 6 is 540, right? 90 into 6 is 540. This is very close to 6. I mean, this is very close to 540, right? So I can say approximately 6 times. Remember, we are doing an approximate calculation. Don't waste your time in doing a precise calculation here. So 550 upon 90 is roughly 6, very close to 6. 6 by 2 is 3. 6 by 2 is 3. So this results in what? 90 plus 3. 90 plus 3 is 93. And hence that's your answer, 93. Look at the options now, 95, 91, 93. Which is the best one? 93 is the best one. Hence 93 is the correct answer. The same process can be done with respect to 10,000 as well. So in that case, what do you do? 100 minus 1350 divided by 2 into 90. Do the same calculation, you will know that 95 and 91 also will get eliminated. So 93 is the final answer to this question. Alright, so this is how you find out approximate square root of a given number. Alright, try to take a range where both the numbers are perfect squares so that it becomes easier for you to evaluate, right? And then considering that as the base, plus or minus the difference of the original question, I mean of the value given in the question and the value that you have considered, divided by 2 times of the value that you have got here, right? That's the process. Let us now take the next example from this topic of approximations, where we'll deal with approximate cube roots. So the question given here is find the approximate value of the cube root of 58,935. Options are 42, 39, 67, 28 and 51. So basically here we have to find out the approximate cube root of 58,935, right? So what comes in place of question mark? And like we discussed earlier, what is important in approximations is, you know, the options. So if you see the options here, not very closely spaced out, 42, 39, 67, 28, 51. So it gives us enough cushion to do an approximate calculation, right? If the options were really close, let's say if the options are like 42, 43, 44, 45, 47, then we'll have to do a very precise calculation. But here I think we can do a rough calculation to find out which of these options is the right answer, right? And remember again, in approximations, the idea is to find out the best answer. There's nothing like the accurate answer or the right answer, right? The best answer, the best of the given options has to be chosen here. So which is the best option? Now, before we look into the actual trick of finding out approximate cube root, let's first understand if we can solve the question just based on the range of the question here. Like for example, if I list down all the cubes, like 10 cube, right? What is 10 cube? It's 1000, right? 20 cube. What is 20 cube? 8000, right? Then 30 cube. 30 cube is 27,000. 40 cube is gonna be 64,000, right? Then we have 50 cube, which will be 1,25,000, right? 60 cube is equal to 2,16,000. I mean, you know all these values, right? 70 cube will be 3,43,000. 80 cube will be 5,12,000. 90 cube will be 7,29,000. And then 100 cube you all know is 10 lakhs, right? So these are the cubes that we all know, right? 1 to 10 cubes is, you know, something that you all would be aware of. Then 10 to 100, I mean 10, 20, 30, 40 cubes and so on. Now if you see, the given value here is 58,935. Just look at the cubes that we have listed out here, right? And compare with the given value. 58,935 is the question, right? We have to find out the cube root of 58,935. Now here, if you observe the table that we have put up, 20 cube is 8,000 means what? The cube root of 8,000 is 20. Cube root of 27,000 is 30. Cube root of 64,000 is 40. Right? Cube root of 1,25,000 will be 50. Now the point is, if you see 58,935 is more than 27,000. You get the number. 58,935 is more than 27,000 and less than 64,000. So I can say that the value given in the question is between these two numbers, 27,000 and 64,000. And hence, the answer has to be between 30 and 40. Yes or no? That's what is meant by establishing the range, right? If I go by the range, 58,000 lies between 27,000 and 64,000. Hence, the answer has to be between 30 and 40. Look at the options. Look at the options and see how many of these options are in the range of 30 to 40. Option number 1, 42. It's more than 40. See, 40 cube itself is 64,000. 42 cube will be more than 64,000, but the number given here is less than 64,000. Hence 42 is ruled out. 39, yes, it satisfies the range. It is between 30 and 40. So maybe an answer. See, you cannot mark 39 as the answer immediately. You know, just because it satisfies the range doesn't mean that it's the correct answer. You'll have to do, you'll have to verify the other options as well, right? Now, if you look at third option, 67, out of range, right? Not between 30 and 40. 28 again, not between 30 and 40. It is less than 30. It cannot be the answer, right? Because 30 cube itself is 27,000. 28Q will be less than 27,000, and the value here is more than 27,000, of course, right? So fourth option is also ruled out, and so is fifth option, 51. So if you see, if I just go by the range, option 2, 39 comes out to be the correct answer. How much time would it take in the exam? It will just take about 5 to 8 seconds for you to evaluate this. You need not write all these numbers on paper, right? You know that 58,000 lies between 27,000 and 64,000, which are perfect cubes, 30 cube and 40 cube respectively. Hence answer should be between 30 and 40. So 39 can be taken as a correct answer. And believe me, actually there have been exams where these kind of questions have been asked, right? It's not that options have been made up here such that only one option satisfies, right? But then yes, there can be a situation where all the options satisfy the given range, or multiple options satisfy the given range, or let's say options are not given at all. You may have to find out the approximate cube root of a number for finding out some other answer, for solving some other question, bigger question, right? So in that case, what do we do? So basically, if more than one option satisfies the range, then how do we come to the conclusion, right? How do we decide what the right answer is? Now, in the topic of speed math, we have already dealt with cube roots. We know how to find out cube root of a given number. But there, the condition that we had talked about was that the technique is applicable if and only if the given number is a perfect cube. Now here the given number 58,935 is not a perfect cube. How do we know it's not a perfect cube? Generally perfect cubes will not end with 35, right? A perfect cube will not end with 30. In fact, the fact that question has been given under approximation means that you have to do an approximate calculation. I mean, more than anything else, right? See, basically, just by looking at the number, telling if it is a perfect cube or not is going to be a very difficult task. It's not really easy that way, right? But then keep one just simple thing in mind. If the question is under simplifications, consider the number to be a perfect cube. If the question is given under approximations like this one, consider it to be an imperfect cube. So for such an imperfect cube, 58,935, how do you know what the cube root is, right? I repeat, the technique that we have discussed in speed math is applicable only for perfect cubes. The two-step process, very, very simple technique, right? But here that technique will not hold true. So we have to use some other technique. Now, how do we get the answer? Simple. Again, like what we had seen in case of approximate square root, right? We will try to find out the nearest cube root that we know, nearest perfect cube that we know, right? Like for example, if I say 58,935, we have already looked at the range here, right? It is between 27,000 and 64,000. Answer should be between 30 and 40. So we can, do some, we can apply that regular process, something similar to what we discussed in square roots, approximate square root, and get the answer. There will be slight change here, but again, you can get the answer using that kind of a method. However, before solving this question, let's take a simpler number, right? Instead of dealing with 58,935, let's say we have to find out the cube root of 2,50,000. What is the approximate cube root of 2,50,000? Again, 2,50,000 is not a perfect cube because a perfect cube will not have 4 zeros. It will have 3 zeros, 6 zeros, 9 zeros, right? It will have the number of zeros in a perfect cube will be a multiple of 3. Yeah. Anyway, this is not a perfect cube. You have to find out the approximate cube root. Again, go by the range. You know that 2,50,000 lies between 2,16,000 and 3,43,000. Right? 2,50,000 is between 2,16,000 and 3,43,000. Hence, the answer should be between 60 and 70. But unfortunately, we do not have options here. If options were given, we could have eliminated the wrong answers and would have been left out with the right one. But options are not there. So how do we solve? What do we do? The process again starts with the same idea, right? Get the range, get the two numbers. So I can say that 2,50,000 is between these two values, 2,16,000 and 3,43,000. Yes or no? It is greater than this and less than this. So if I have to find out cube root, a similar range would be applicable. Meaning cube root of 2,50,000, which is question mark, will be less than 70, but will be greater than 60. Right? Between 60 and 70. Because cube root of 216,000 is 60 and cube root of 343,000 is 70. Now what do we do? This question mark will be equal to same process. Let's say 2,16,000 is the base. 2,16,000 is the base. So what do we do? Since the cube root of 2,16,000 is 60, consider 60 here. I know that the question mark is going to be greater than 60. You see, question mark is greater than 60 according to what we have understood here. So 60 plus something. 60 plus something. Now what is that something is the question here. What is that something is the question here. Remember, what did we do in the case of approximate square root? We find out the difference between the given value and the number that we have considered. So basically here you have to take the difference between 2,50,000 and 2,16,000. So 2,50,000 minus 2,16,000. divided by, the only difference here comes in the denominator. In case of square root, what did we do? We have taken twice of 60, right? We would have taken twice of 60, but here it cannot be done. And some of you are thinking that here we should take thrice of 60, even that is incorrect. You know, just because it was square root, we have taken twice. So since it is cube root, we have to take thrice. That's not the technique. Here the denominator completely changes. Here in denominator, you're supposed to take the difference of the two numbers that you have considered, 2,16,000 and 3,43,000. You're getting it? 60, you know how we have obtained that, right? 60 is nothing but cube root of 2,16,000. So 60 plus something. That something numerator is the difference between the given value and the value that you have considered here. So 2,50,000 is how much more than 2,16,000? What is the distance between these two numbers? The denominator changes. In the denominator, you have to take 3,43,000 minus 2,50,000 and multiply this result by 10. Multiply this value that you get here by 10, because see, the range is going to be 10. I mean, it is 60 to 70, between 60 to 70, right? I mean, that way, just multiply it by 10. Or remember it as a technique. So 60 plus the difference between the given number and the number that you have considered, divided by the difference between the two numbers that you have considered. Always take two numbers like this, right? Between 60 and 70, or between 30 and 40, or between 80 and 90, or 70 and 80. So take the difference of 70 cube and 80 cube based on the case there, right? As the case is. Now simplify this, see what happens. So the difference between 2,50,000 and 2,16,000 is how much? 34,000. Yes or no? This is 34,000. Okay. Divide by, what's the difference between 3,43,000 and 2,50,000? Oh, I'm sorry, here in the denominator, I'm so sorry. In the denominator, we are supposed to take 2,16,000. Let me clear this. We are supposed to take 2,16,000. The two numbers that we have considered, not 2,50,000. Just keep that in mind, right? Numerator will be the given number difference, the number that you have already considered, divided by the denominator is going to be the difference between the two numbers that you have considered in the range, 2,16,000 and 3,43,000. Okay, so 34,000 divided by, how much is 3,43,000 minus 2,16,000? It will be 84 plus 43. So I think 127, right? This is going to be 127,000. Or if you simply want to forget about zeros, it's going to be 34 by 127 into 10. So the answer here is, it will be equal to 60 plus 34 by 127 into 100. 120, so 127 into 10. 127 into 10. Now all we need to do is simplify this. The better simplification you do here, the closer the answer that you get here in terms of approximation, the better your overall answer is going to be. You're getting it? So I think I can say both are, see, one way is I can say 34 by 126 is roughly 1 by 4. 34 into 4 will be 136, right? 34 into 4 is 120 plus 16, 136. So I can say this is 34 into 1, this is 34 into 4, approximately. But then 136 is actually far away from 127, right? Not that close. So let's do something else. Maybe this is like 7 into 5 and 7 into, let's say 70 plus 56, right? So 7 into 18, yeah. See, 7 into 5 is 35. So 35 is very close to 34. And 7 into 18 is 126. 70 plus 56, 126. So very close, right? 34 and, I mean, we are considering 34 as 35 and 127 as 126. So 7 into 5 and 7 into 18. So basically 50 by 18. 60 plus 50 divided by 18. What is 50 by 18? See, 54 by 18 is 3. 5 into 10 is 50 here, right? 50 by 18, approximately 3. Yes or no? Because 54 by 18 is 3, this is approximately 3. So I can say all this results in approximately 3. Approximately 3. So 60 plus 3, 63. 63 is going to be the answer. Yes? So the cube root of 2,50,000. Cube root of 2,50,000 is approximately 63. Approximately 63. Again, like what we discussed in case of square roots, you need not always consider 2,16,000 as a base. You can consider 3,43,000 also. All you have to do is, in that case, we'll get minus. So let's understand the process once again using 3,43,000 as a base. What happens? We are supposed to find out the question mark. What is question mark here? Cube root of 2,50,000. Approximate cube root of 2,50,000. What do we do? Question mark will be equal to, see, let's consider 3,43,000, right? 2,50,000 is close to 3,43,000 in that sense, right? So 70 cube, I mean, the cube root of 3,43,000 is 70. So 70. It is less than 70. Question mark is less than 70. See, question mark here is less than 70. So less than 70 means minus. Minus what? Take the difference of the given number with whatever number you have already considered. So it will be, difference basically. Don't go by the sign there. So 2,50,000 difference means what? You have to only consider the magnitude. Don't consider the sign again and make minus s plus. Don't do those changes. So 34300 and divide by, again the denominator is going to be 216 and 343. So the difference of 216 and 343. All right, 2,16,000 minus 343,000, or difference 343,000 into 10, right? What happens? So 70 minus, what is the numerator? 2,50,000 and 3,43,000. What's the difference? It's going to be 50,000 plus 43, 93,000, right? So 93 divided by, anyway thousands are going to get cancelled in numerator and denominator, so don't worry about that. 93 divided by, what do we get in the denominator? 127 into 10. 93 by 127 into 10. Yes or no? 93 by 127. Now simplify this. I think this is like 31 into 3. 31 into 3 is 93. 31 into 4 is 124. Close to 127. The only approximation here is we are considering 127 as 124. 31 into 3 is 93. 31 into 3 is 93. 31 into 4 is 124. Very close to 127. So 3 by 4. 3 by 4. 3 by 4 is 0.75. 0.75 into 10, 7.5. So 70 minus 7.5. How much is 70 minus 7.5? 62.5. So we're getting the answer as 62.5. Earlier we got roughly 63. Now we're getting 62.5. So I can say that the approximate cube root of 2,50,000 is going to be 62. Roughly 62.5. Right? So this is how we can find out the cube root of a given number. Approximate cube root of a given number. Now let's do the same thing for the actual question, right? The actual question was 58,935, right? We already know the answer is 39, but how do we do it using this process, right? How do we arrive at the answer using this process? What do we do? Question mark. See, again, no need to write all these steps. All these steps were to make the process clear to all of you. Now you can cut down the number of steps. 58,935 is between 27 and 64. 58,935 is between 27,000 and 64,000, right? So let's take 30 as the base, 30 plus something, right? 30 plus something. It is more than 27,000, right? So answer should be more than 30. 30 plus what? In the numerator, we will have, see, I am roughly taking 58,935 as 59,000. See, anyway, it's approximate cube root, right? So why do we deal with all this 935 and all that? Let's add 65 to this. So 58,935 will become 59,000. Approximately 59,000. So 30 plus, what will come in the numerator? 59,000 difference, whatever you have considered here, 27,000. I am repeating again, this is just the difference, right? Don't worry about the sign here. Okay. Divide by what comes in the denominator? The difference of these two values. 30 to 40 range is what you have considered, right? So 64,000 difference 27,000 multiplied by 10. Simplify. So 59,000 minus 27,000 is what? 32,000, right? Zeros anyway get cancelled. 64,000 minus 27,000 is going to be what? 37,000, right? 37,000. So 32 by 37. 32 by 37. 32 by 37. I think this is like 4 into 8 and 4 into 9. Very close to 4 into 9, right? This is definitely 4 into 8. Exactly 4 into 8. This is 4 into 9. 4 into 9 is 36. Approximately 37. So 8 by 9. 8 by 9. Or 80 by 9. 80 by 9 is approximately 9, right? 8 into 9 is 80. 80 by 9. So 30 plus 80 by 9. If it is 81 by 9, we can take it as exactly 9. 81 by 9 is 9. This is approximately 9, right? Approximately 9. Approximately 9, this value. So 30 plus 9, 39. That's your answer, 39. And see, options, we have got 39. See, there can still be options which are closer to 39. Like there can be one option which is 37. There can be the other option which is 41 and all that. But you know that answer will be less than 40. Answer should be closer to 39. So choose the best of the given options. Right? It's always about best of the given options. Whether it's approximate cube root, approximate square root, or any question based on approximation. All you have to do is find out the best of the given options. Okay. So among the given options, the best one is what you can always take as the answer. So this is how you deal with finding out approximate cube root. Remember, it's slightly different from finding out approximate square root. In approximate square root, the denominator here is nothing but twice of whatever value you have considered here. 2 into 60. Here it will be 2 into 70. In this case, it will be 2 into 30. But in case of approximate cube root, the denominator is the difference of the two numbers that you have considered in the range. Right? Always the difference of the two numbers that you have considered in the range. Now that we have learned how to find out an approximate cube root and an approximate square root, let's look at a typical question that comes under approximations in bank exams. So what we see on the screen here is a question from approximations which goes as follows, right? Square root of 727.9995 plus 5.1961 squared is equal to question mark divided by 2 by 10.7960. And look at the options here: 53, 44, 5, 15 and 10. So our job here is to find out what comes in place of question mark, right? We have to find out what is the value that comes in place of question mark, right? In fact, what is the approximate value that comes in place of question mark? Now, as you can observe from the options here, these are not very close to each other, right? 53, 44, 5, and then we have 15 and 10, right? These options are spaced out properly, which means we can do approximation to a good extent here. See, if the options are very close, like 53, 52, 51, 49, then it becomes a little challenging, because even a small error in your approximation can lead to a wrong answer. But since the options are far away from each other, right, we can do a approximation to a good extent, right? So how do we deal with it? Now, it's all about taking the closest values possible. Like for example here, 727.9995 is very close to 728. So this can be considered as square root of 728 plus. Now we have 5.1961 squared. Now there are two things that you can think of. Either you take it as 5.2 square, which is very close to 5.1961, or you can also take it as 5 squared. Now I am okay taking it as 5 square here, since the options are not very close to each other. If the options had been very close, like 44, 43, 42, 41, 39, then we should have taken this as 5.2, right? But in this case, I think we can consider it as 5 square, which is equal to question mark divided by 2 by 10.7960. Now 10.7960 can be approximated as 11. So this is what we need to deal with, right? Find out what comes in place of question mark. Now see, 728 under root is very close to 729 under root, right? Square root of 729, and square root of 729 you know is 27. So this is approximately 27. 5 squared, 25. So we have 27 plus 25 on the left hand side, which is equal to question mark. Now we have learned in simplifications, when you have division followed by a fraction, easier way to deal with it is convert this division to multiplication and reciprocate the fraction. So 2 by 11 becomes 11 by 2. Right? So the question now boils down to 27 plus 25 is equal to question mark into 11 by 2. It was question mark divided by 2 by 11. It has been changed to question mark into 11 by 2. We have learned this in simplifications. You can refer to those videos for more details. So what do we have now? 27 plus 25 is 52. 52 equals question mark into 11 by 2, or it's like 11 by 2 you know is 5.5. 5.5. Now 52 by 5.5, right? Approximate value of question mark is 52 by 5.5. If I take it as 53, I mean if I take it as 55, 55 by 5.5 is 10. Or if you consider 5.5 as 5.2, approximately it is close to 10, right? Somewhere around 10. Now look at the options. 53 and 44 are straight away ruled out. These are no way close to 10. 5 and 10 are also far away from 10 when compared to the option 5 here, which is equal to 10. You're getting it? See, understand, in case of approximations, it's not about right answer from the options. It is about the best answer from the given options. So the best of the options here is 10, because what I get here is something which is very close to 10. Slightly less than 10 if you look at 52 by 5.5. But yes, it can be considered as 10, which is given in option 5. So your answer to this question is going to be option 5, 10. So this is how you deal with questions in bank exams. Let us now look at example number 4 from approximations, where we will deal with a question based on fractions. So the question here is 1 4 by 7 plus 7 1 by 3 plus 3 3 by 5 is equal to what? And we have to find out what comes in place of this question mark, right? Approximately what comes in place of this question mark. Options are 21, 8, 25, 13 and 30. Again, in this case, if you throw a look at the options, you would realize that they are not very close to each other. So we can do an approximation to a great extent. Now look at the question. 1 4 by 7 plus 7 1 by 3 plus 3 3 by 5 is equal to what? Now if you recall our discussion of simplifications, we had dealt with questions based on fractions there as well, and the technique that we had learned there was whenever we have to solve a question based on fractions which involves additions and subtractions, it is always suggested to deal with the integers part separately and the fractions part separately, right? Whenever we have additions and subtractions involving fractions, right, or fractions involving additions and subtractions, it is best to do the integer solution separately and the fraction solution separately, and then club these two to get the final answer. There is no point in simplifying this fraction. Like 1 4 by 7 can actually be taken as 7 plus 4 11 by 7. Then 7 1 by 3 can be taken as 21 plus 2 22 by 3. And similarly 3 3 by 5 can be simplified as 18 by 5 is equal to what? But then this makes no sense. This will only, make the solution lengthy. So it's always best that you deal with integers and fractions separately. So let's find out the integer value first. See, all are additions, right? All the three values have to be added. So 1 plus 7, 8, 8 plus 3, 11. So 11 is the integer sum. Now what is the fraction sum? See, even if I consider all the fractions here equal to 1, like 4 by 7, 1 by 3 and 3 by 5 are the three fractions. 4 by 7 is one fraction, 1 by 3 is another fraction, and 3 by 5 is the third fraction. See, understand that the maximum value of a fraction can be 1. In fact, it should be less than 1. It can be like 0.9999, right? The maximum value that any fraction can take is 0.999 and so on. 1 becomes an integer, right? Maximum can be 0.99. Like for example, let's say if it is 48 by 49, this will be very close to 1, right? Or 73 by 74. These fractions are very close to 1, right? So even if you consider all three fractions here, 4 by 7, 1 by 3 and 3 by 5 to be equal to 1, 1 and 1, let's say. Actually, these are not equal to 1. These are less than 1, right? 4 by 7 is less than 1. 1 by 3 is like only 0.3. 3 by 5 is 0.6. But even if we consider it to be 1, 1 and 1, what will be the maximum sum that we'll get here? 3. The sum of the fractions is going to be 3. So 11 plus 3, approximately 14 has to be the answer. Yes or no? The answer for this arithmetic sum of mixed fraction should be 11, which is the sum of integers, plus 3, which is the sum of the fractions, 14. Look at the options. Is 21 a possible answer? No. Is 8 a possible answer? No. Is 25 a possible answer? No. Is 30 a possible answer? No. 13 seems to be close to 14. See, answer definitely should be between 11 and 14. Because integer sum is 11, right? Question mark will be greater than 11. Why will it be greater than 11? Because integers itself are adding to 11. So it should be greater than 11. And it should be less than 14. Why it should be less than 14? Because all the three fractions, if considered as 1, 1 and 1, the maximum value that this question mark can take is 14. So it has to be between 11 and 14. And the only option which is between 11 and 14 here is option 4, 13. So that becomes our answer. You don't have to write all these steps to get the answer, by the way, right? All this can be cut down. You can mentally do the simplification or the approximation and mark option 4 as the answer, right? Suppose the options are really close, then you may have to deal with the fractions part properly. Like if the options, let's say, are 13, 13.5, 14, 11.7 and something like that, then you may probably have to deal with the fractions a little carefully, right? What will happen? 4 by 7 plus 1 by 3 plus 3 by 5. Integer sum even in that case would remain 11, right? Integer sum will not change. That will remain 11. Only the fractional part would change. Simplify, how much will that become? See, 4 by 7 is approximately 0.5. How can I say that is approximately 0.5? Because 4 by 7 is like 4 by 8. 4 by 8 is half 0.5. 1 by 3 we all know is 0.33, but we can consider as 0.3. And 3 by 5. See, if you recall our discussion of percentages in speed math, 3 by 5 is 60%, and 60% is 0.6. So if I add all the three fractions, it will be 0.5 plus 0.3 plus 0.6, which is 0.8 plus 0.6, 1.4. Right? This is 1.4. So the integer sum is 11. The fraction sum is 1.4. Yes or no? So what we had taken as 3 is actually 1.4. So what happens? 11 plus 1.4 will become 12.4. 12.4. And again, 12.4 also, the best option that we have among the options here, 13. Option 4, 13. Getting it? Anyway, let me tell you that we need not do this kind of a precise calculation for fractions here, because only one option is close to what it can be approximately the value there. Right? In case the options are close, 13.5, 11.5, 13 and so on, then you may have to probably go for this kind of a calculation and mark the answer as 12.5. Right? In that case, the answer can be taken as 12.5 if it is there in the options, or it can be taken as 12, whichever is closest. So this is how you just deal with questions based on fractions. Similarly, let's say instead of plus, we have minus somewhere. Like for example, if we have minus 3 by 5, what do you do in that case? Let me use a different color to explain that, right? Let's say we have, instead of plus 3 by 5, we have minus 3 by 5. So what happens? 1 plus 7, 8, 8 minus 3. right? 1 plus 7 is 8. These two have to be added. 1 plus 7, 8, and 3 has to be subtracted. 8 minus 3 is what? 5. So the integer sum is going to be 5. Plus, what's the fractional sum? 0.5 plus 0.3. This 0.6 will become minus 0.6. Plus 0.6 will become minus 0.6. See, remember, when you have minus 3 by 5, integer becomes minus 3, fraction becomes minus 3 by 5. You cannot add 0.6, you have to subtract 0.6. So 0.5 plus 0.3 is 0.8. 0.8 minus 0.6 is 0.2. So 5 plus 0.2, approximately 5.2. So suppose if it is minus 3 by 5, then what comes in place of question mark? It will be approximately 5.2 or 5, depending on the options given. So simple. Whenever you have to deal with fractions based sums, right, where you have to do additions and subtractions, the best way to simplify is to take the integer sum separately and the fraction sum separately, right? So 1, 7, 3, and then 4 by 7, 1 by 3, and 3 by 5.
Let's look at the solution for this one. Now, approximate calculation, we are required to do an approximate calculation. Clearly it says you're not supposed to get the exact answer. So try to do an approximation. I would say rather than changing the percentages, let's change the values here. Instead of approximating the percentages, let's approximate the values. So 5,647, is it close to 5,650? Very close to 5,650. So we are taking it as 5,650 plus, so as it is 89% of 5,650 plus 27% off. What about this one? 4,589, close to 4,600, 4,600. And remember, we have increased both. This has been increased minimum just by 3, right? The difference is 3. This has been increased by 11, right? But again, we are taking 89% of that 3. That is going to be the difference, and only 27% of that 11. So minimum difference is going to come in the answer that we obtain and the exact answer there, right? So we don't have to worry about answers being close. I think if you do this part clearly now, a bit properly, you'll be able to mark the answer. Now look at this, 89% of 5,650. It all depends on how do you do this calculation and how do you do this calculation. I don't think we need to do any approximate calculation there. You can do the exact calculation. What do you do? 89% of 5,650. 89% is what? 100% minus 10% minus 1%. Yes or no? 89% is equal to 100. I am writing this, but as such, it is not required to be written on paper. It's all your understanding there, right? So 100% is how much? 5,650. This should be visualized. I mean, I'm writing so that I can explain you, but try to visualize. So 5,650 minus 10% of 5,650, 565 minus 1% of 5,650, 56.5. So what will this be? 5,650 minus 565 minus 56.5. 565 and 56.5. How much is that? Around 620, 620. So I can say this is going to be around 5,000. Yes or no? Close to 5,000. Close to 5,000. Are you able to follow? Slightly more than 5,000 in fact. 5,650 minus 565 minus 56.5. 565 and 56.5. How much is that? 565 and 56.5. It's going to be 620, close to 620 or 620, 620.5, 621.5, right? So 620, 5,650 minus 620 will be 5,000, or I can say 5,030, let's say. I mean, if you want to go for a precise calculation, right? 5,030. So that's the first part, 5,030. Plus what? 27% of 4,600. What is 27%? If you ask me, 27% is 20% plus 5% plus 2%. Keep it simple. Yes or no? 20% plus 5% plus 2%, or 30% minus 3%, or 25% plus 2%. Anyway, whatever is comfortable for you. 20%, 10% is 460, 20% will be double. 460 into 2. How much is that? 920 plus 5%. 10% is 460, 5% will be 230 plus 2%. 1% is 46, 2% will be 92. Values 920 and 230. How much will that be? 1150. 1150 plus 92. Can you take it as 1240? Approximately. In fact, 1242, 1240. So this part is 1240. Now add 5,030 plus 1240. So 6,040 plus 30, 6,070, close to 6,000. Sorry, 5,000 plus 1240 will be 6,240. 6,240 plus 30, 6,270. 6,270. Approximately 6,270. Which is the best option? This is far away. This is close. This doesn't seem to be close, because understand, we haven't moved really far away from the exact answer. That's what I was trying to tell you, right? We have just increased by 3, And when you take the actual difference, net difference, it is not actual 3, it is 89% of 3. It should be around 2.7 or less than that. Again, here also, we have not increased by 11. We have increased by 27% of 11. Are you able to follow? That is going to be the net difference. And here again, we have done almost very precise calculation. So we are very close to the exact answer. So I can say 6265 seems to be correct. Though, I mean, this anyway is ruled out, not close to 6270. 5955 also can be ruled out, right? So the correct answer here has to be 6265. And you also know that answer should be slightly less than this because values were increased. Actual answer will be less. Slightly less than that, 6265 seems to be correct in all the ways there, right? So second option, 6265. So it's all practice, I would say, right? Approximations is more to do with practice. The more you practice, the easier it becomes, right? So that's how you can solve questions related to approximations. 24.3 should be multiplied with 36.3. What is 24.3 into 36.3? Approximate calculation again. You are required to do an approximate calculation. So what do? I mean, the first idea that we get here, is this is 24 into 36. Let's say approximately 24 into 36. 0.3 and 0.3 is neglected. So 24 into 36. What is 24 into 36? It will be 864. 30 plus 6, 30 minus 6, 30 square minus 6 square, 864, right? So you know that 24 into 36 is exactly equal to 864. So can you say approximately 24.3 into 36.3 is also 864? Based on the options again. If the options are close, you'll have to go for the precise calculation. If the options are not too close, then whichever is close to 864 can be taken as answer. Obviously, the answer should be more than 864. Why it has to be more than 864? Because the actual values are more. 24.3 is more than 24. 36.3 is more than 36. So when you multiply two larger values, obviously the product will also be larger. So answer has to be more than 864. So that's the first thought that you get. Look at the options. If there's only one option which is more than 864, mark that as answer. Again, more than 864 doesn't mean that it will go in 1500 or 2000. Close to 864, right? Now, if at all there are more than two options, or let's say there is more than one option which is close to 864, and both of them are more than 864, then how do you decide which one is correct? So here, next, what we need to understand is how much approximation have we done? Are you able to follow? How much far away are we from the exact answer? Try to understand. I'll split 24.3 and 36.3, and let's understand what actually happens here. For example, if I take 24.3, you know that 24 into 36 is 864. 24 into 36 is equal to 864. So just keep this in mind, and let's understand how much close or how much far are we from the exact answer, right? The exact answer is not known to us. We'll not even calculate the exact answer, but let's understand the process. So 24.3, if I take it as 24 plus 0.3 into 36.3, if I take it as 36 plus 0.3, what happens? A plus B into C plus D. So you know that each term must be multiplied. 24 must be multiplied with 36, 24 must be multiplied with 0.3, 0.3 must be multiplied with 36, and 0.3 must be multiplied with 0.3. So 24 into 36 is one step, plus 0.3 into 36 is the next part, plus 0.3 into 24, or 24 into 0.3, plus what is the fourth term? 0.3 into 0.3. Now look at this. What have we actually done? We have considered it to be approximately 864. So if there's only one option, you know the answer. But how do you get the answer when more than two options satisfy, or more than one option satisfy 864 range there? 24 into 36 is 864. This anyway we know. We need to take care of the remaining terms. Again, when it comes to remaining terms, 0.3 into 0.3 doesn't really matter. I mean, what is 0.3 into 0.3? 0.09 or 0.1. Yes or no? 0.09, approximately 0.1 we can say. So this part can be neglected. But the remaining two terms cannot be neglected. For example, what is 0.3 into 36? Just think of this. 0.3 into 36. 3 into 36 is 108. So 0.3 into 36 will be 10.8. Plus, what is 24 into 0.3? 24 into 3 is 72. So 24 into 0.3 will be 7.2. Plus, again, if you look at this part as well, 0.3 into 0.3 will be 0.09. If you really understand, what we have initially considered is 864. That's the best way to do it, right? If at all more than one option goes in the range of 864, then consider these parts as well. 10.8 plus 7.2. How much is that? 18. Now try to understand. When you take 24.3 into 36.3 as 24 into 36 approximately, you don't get a difference of 1 or 2, right? Generally, we feel that maybe a difference of 1 or 2. No, that's not the idea. The difference here will be how much? Is around 18. Yes or no? 10.2 plus 7.2 is 18. That means the actual answer 24.3 into 36.3 should be 864 plus 18 plus this part 0.09. What is 864 plus 18? 882. 882 plus 0.09. 882.09. That's the exact value. But then we are not required to find this one. The question clearly says that you are not supposed to calculate the exact answer. We are supposed to do an approximate calculation. So this can be neglected. But then based on the options, you cannot avoid this part. And again, let me tell you, when you actually do the calculation here, you don't have to write the step-by-step process. It's just understand 24 into 36, 864, 0.3 into 36, 0.3 into 24. Right? Or here again, if you take 0.3 common, I can say 24 plus 36 is 60. 0.3 into 60 is 18. But always it may not be possible. For example, if it is 24.3 into 36.8, let's say, then again what do? 4 terms you will get. Here 0.3 can be taken common. If some of you have got the idea of taking 0.3 common, good, well and good. But that's not possible always. So this is something which you need to keep in mind. What is that? You do an approximate calculation. I don't say that 864 is wrong. 864 is approximately correct. But again, here the answer depends on the type of options given to us. Are you able to follow? Generally, if the question is on simplifications, there is a fixed answer. Only when you get that, you will get the right answer. You will get that 1 mark. But approximations, it depends on how much of approximation has been done, and that is only based on the given options. Right? So remember, while solving these questions from approximations, always you have to take care of the options there. Look at the options. Understand, right? To what extent you can go for approximation. If the options are too close, maybe you leave the question if you find it really very close. If they are not so close, then try to first go for 864. Then see if 864 is giving you the right idea or not. If not, just check 0.3 into 36, 0.3 into 24. Likewise for 3-digit numbers, 4-digit numbers, same idea. Just try to go for an approximate way of getting the answer. Again, based on the options. Let me tell you why I have taken division, multiplications here, because divisions generally doesn't matter. Divisions, when you do this approximation, suppose 0.3 is neglected in the numerator and 0.3 is neglected in the denominator, you don't get much of a difference. But multiplication, you get a lot of difference, right? So that is the reason we have taken multiplications as the case here, as the example. Again, while solving the questions, we look at divisions as well, additions and subtractions, right? So just keep this in mind. The other point which I would like to tell here is, though this may not be really useful, but remember, whenever you are doing multiplications, never increase both the values or never decrease both the values. Now you may tell here that you only have decreased both the values. Yes, 24.3 we have taken 24, 36.3 we have taken 36, but then ideally you should not decrease both the values. You will get an answer which is far away from the exact answer, or you should not increase both the values. Increase one, decrease the other in multiplications, right? Are you able to follow? For example, when I decrease 24.3 and increase 36.3, what happens? This reduction will reduce the answer. This increment will increase the answer. So it's balanced. One is decreasing, the other is increasing. So somehow it gets balanced. If I decrease both of them, what happens? Because 24.3 has become 24, our answer will get reduced. 36.3 becomes 36, our answer gets further reduced. So you are moving far away from the exact answer, right? But generally this doesn't happen. I mean, we don't have to really worry about this, but just keep this in mind. Multiplications, it's ideally suggested that you increase one, decrease the other. If you decrease the first one, increase the other one. And that this happens only when you're changing both of them. If at all you're changing only one of them, then doesn't matter. But when you change both the values, just try to follow this, right? But then more than that, what is important is you must be able to understand how far are you from the exact answer. 864 plus somewhere around 20. So 884 you can say, 882 you can say, and mark the given options. But when it comes to divisions, as I mentioned, generally it doesn't matter. There's not much of a difference. But remember, in divisions, either increase both numerator and denominator or decrease both numerator and denominator. If at all you change both of them, if at all you want to change both the values, both numerator as well as denominator, do a similar change. Increase both or decrease both. Never increase the numerator and decrease the denominator, or decrease the numerator and increase the denominator, because these will give you extreme answers. You have to be in the mean range, right? Close to the exact answer. So when you increase both, you'll remain close to the exact answer. When you decrease both, you'll remain close to the exact answer. But when you do opposite changes in numerator and denominator, either you will fall on that side, higher side, or the lower side. So just try to understand this. I mean, you may not necessarily apply this always. I mean, you don't have to worry about this too much in the exam, but then just keep this in mind, right? That's something which you need to understand. Same thing happens for additions and subtractions, right? For example, when you're adding two numbers, let's say 18 and I have to add 18 and 29, right? I mean, this approximate calculation is not required. You can anyway get the exact answer, but I'm just giving an idea. What do? Don't increase both the values. or don't decrease both the values. That's a wrong approximation. Increase one, decrease the other, or decrease one, increase the other. If at all, again, you want to change both of them. Because when you increase both of the values, both the ways you are going away from the answer. When you decrease both the values, you are moving away from the answer. Increase one, you move away, move up. Decrease the second one, you come down. So that's how you try to balance, right? So additions and multiplications always do opposite changes. Subtractions and divisions always do same changes, similar changes, both increase or both decrease, right? So just try to understand, just keep this in mind. Let's now take some examples, right? So this is important. How much away are you moving from the exact answer? I think I'll take one more example here of multiplication, because this actually gives a lot of difference. 362.8 into, you have to multiply 480.6 equals to what? Or let's say 484.6. We'll not do the exact calculation. Approximately, you know, 362 into 484. Check the options. If there's only one option in that range, you can mark the answer. But what you need to understand is, understand that how much far or how much difference will you get when you check with the exact answer. And that only depends on these decimal parts. Simply don't neglect them. Don't neglect 0.8 and don't neglect 0.6 here, right? Understand how much far away will you move. 0.8 into 0.6, you don't have to worry. As I've mentioned in the previous case, the last part generally doesn't matter. What matters is the second and the third part. 0.8, see, 362 into 484 is the first step. So that anyway you will do. But 0.8 into 484, how much will that be? Try to understand. Will the difference be in tens? Will the difference be in 10, 20, 30, 40? Will the difference really be 10, 20? I mean, the difference of exact answer and approximate answer. No, the difference will go in hundreds. Look at this. 0.8 into 484. How much is that? 0.8 into 484. 484 into 1 is 484. 484 into 0.8 will be approximately 400. Yes or no? 484 into 0.8 into 0.8. How much is this? 484 minus 96, I should say, or 96.8, I should say. So approximately, I can say this will be around 487. 487. Are you able to follow? Sorry, not 487. 387. 484 into 0.8, 387. That means just because you neglect 0.8, you will get a difference of 387 in the answers. This is important. These things you must understand. And only then you'll be able to mark the right answers. Likewise, if you take 0.6 into 362, 362 into 0.6, how much is the difference? 0.6 or let's say 0.5. Half of 362 is how much? 181. More than 181. 181 plus 36, I can say, if you multiply with 0.6. Right? So it will be around how much? 180 plus 36, 216, 217, approximately 270. So look at this. Just because we neglect 0.8 and 0.6, we are getting a difference of how much? 600. 600 is the difference. Yes or no? Isn't that surprising? So understand, neglect, 0.8, 0.6 neglect, but depends on options again, right? You must be able to do this approximate calculation quickly. That answer will be actually 600 more than what you get when you multiply 362 and 484. And then add that 600 and check. You don't have to worry about 0.8 into 0.6. What is 0.8 into 0.6? 0.48. 0.48 is 0.5, half. That doesn't really matter. What matters is this difference here. So this kind of calculation you must practice. And believe me, approximations is more to do with simplifications. If you're strong in simplifications, you will automatically get strong in approximations. And simplifications again depends on your speed maths. How quickly do you multiply? How quickly do you add, subtract, or divide? So it's all based on practice, practice, and more practice. 1504 into 5.856 minus 24.091 is equal to what? Options are 7,200, 9,500, 6,950, 5,480, and 8,800. Now, you know that while doing any kind of simplification, you have to stick to the BODMAS principle, right? First divisions, then multiplications, additions, and subtractions when it comes to the basic arithmetic calculation. So here we'll always have to go for multiplication first and then subtract this value to get the required answer. But as I've mentioned in the beginning of this session, before you actually look at the question, you're supposed to throw a glance at the options and get an idea of what kind of approximation can you do. I mean, to what extent can you go for an approximate calculation? Look at the options: 7,200, 9,500, 6,950, 5,400, 8,800. I mean, options are not too close to each other, right? So try to do a very approximate calculation, right? You need not be sticking to very precise calculations, right? So look at this. 1504 is approximately 1500 and 5.856. Can I approximately take it as 6? Yes or no? Again, understand, we are decreasing one value, increasing the other value. I mean, try to maintain this as much as possible. So I'll take this as 1500. Don't take this as 5. You'll be moving far from the exact answer, right? Take it as 6, right? Take it as 6. So 1500 into 6 minus 24.091 is what? 24. And I don't think this is any bit difficult, right? 1500 into 6. What is 1500 into 6? 9000. 1500 into 6 is 9000. 9000 minus 24. 8,976. Look at the options. Do you find 7,200 close? No. Do you find 9,500 close? No. What is our approximate answer? It is 8,976. 9,000 minus 24. So cannot be the answer. Killed. Cannot be the answer. Kill it. 6,950. No way close. No way close. We are left with 8,800. That's the answer. And maybe the exact answer will be close to 8,000. Now don't again worry about why the answer is differing by 200, approximately 200, right? 8,976 and 8,800 is what? 176 is the difference. You know why? We have already learned this because we have taken it as 6. How much more? 0.144 more. But that 0.144 is being multiplied by 150. Are you able to follow? So approximately 0.144, 0.15 times of 1500 will be close to 200 to 25, right? So the point here is we are not trying to find out what is the right answer. We are trying to find out what cannot be the answers. 7,200 is not the answer. 9,500 is not the answer. 6,950, 5,480 are not the answers. Hence, fifth option 8,800 can be taken as a correct answer. For the same question, if the options are given as 8,800, 8,801, 8,802.76, 8,802.85, it becomes difficult, right? Then you have to decide. Can you really be able to mark the correct answer even if you try to do it on paper? Right? If you feel yes, go for the calculation. Otherwise, just leave it, because approximations, if the options are too close, you generally have to avoid those kind of questions there, right? So that's how you can go for approximate calculations. Now, you may also be wondering that maybe intentionally we have given the options in this way so that 4 of them get eliminated. What if in the exam it doesn't get eliminated? Believe me, this question is one of the previous SBI clerks exam question. In fact, all the questions that we have in the workbook there are previous year's SBI clerks exams, so that you actually get a feel of what kind of questions have been asked. Now tomorrow in the exam they may increase the difficulty level. That's a different story. But then what have been asked so far can actually be done very easily without having to put too much of effort there, right? Let's take the next question. 16.928 is what? 17, approximately 17. 24.75 is approximately 25. 17 and 25, 42. 42 and 5, 47. Answer should be close to 47. Look at the options. In fact, you are required to look at the options before, right? I mean, I did not give the answers because anyway, you can directly mark the answer by an approximate calculation. But when you do it in the exam, remember, look at the options. So 47, we are getting close to 47. Options are 35, 40, 22, 12, 45. Obvious. Fifth option, 45 is the answer, right? Look at this one. Cube root of 7.938 multiplied with 6.120 whole squared minus 4.9256 equals to what? The options are 70, 55, 30, 25 and 90. Now cube root of 7.938, cube root of 7.938. What will be the value here? Cube root of 7.938. Can I take it as approximately 8? What is the cube root of 8? Cube root of 8 is 2. So this part here is 2, approximately 2. What about 6.120 whole square? 6 square, right? 6 square, 6.12, 6.12, approximately 6. 6 square is what? 36. Now 2 into 36 minus 4.9256 can be taken as 5. What is the answer here? 2 into 36, 72. 72 minus 5, 67. Getting the point? 2 into 36, 72. 72 minus 5, 67. Are we close to 67 here? Which option? Which option? 70. First option 70 can be taken as the required answer. Yes, because anyway 7.938 will be very close to 2, slightly less than 2, but 6.12 square will be more than 36. That you need to keep in mind, right? Let's say here if we have got approximately 67, but let's say there's one more option. One option is 70, the other option is 65. In that case, what do you do? 70 is close to 67, 65 is also close to 67. Anyway, 30, 25, 90 are ruled out. But these two are possible. 70 is possible, 65 is also possible. And approximately our calculation says it's 67. So what do you do? 2 into 36, 72 minus 5, 67. Which one is the correct answer? In such a situation, you have to analyze. Will the actual answer be more or less? How do you do that? 7.938, no doubt it's going to be very close to 2 because cubed root, that doesn't really give you a huge difference. But what gives you a difference here is 6.12. We have taken 6 square, but actually it is 6.12. 6.12 square will be more than 36. 36 when 2 when multiplied by more than 36, this will be more than 72. More than 72 minus 5. In fact, less than 5. Answer has to be more than 67. Every step tells that answer has to be more than 67. So that is the reason first option 70 can be taken as a right answer. So that's the approach that you need to follow when two options seems to be close. First decide which is, is the correct answer will be more or less, right? Otherwise, if that situation arises, try to decide this. So otherwise, you can directly mark the answer based on which option is close to the given. Which answer option is close to the answer that we have got, right? 16.046 divided by 2.8 into 0.599 is equal to what? The options are 3.5, 7.9, 1.9, 5.6, 6.2. What do? First division, then you have to go for multiplication, or from left to right you can just proceed, right? That doesn't really matter when there are only multiplications and divisions. Remember, Bodmer's rule says when there are only multiplications and divisions, you can simply proceed from left to right, or do divisions first, then go for multiplications. So anyway, let's look at this. 16.046. This is approximately 16 divided by 2.83 into 0.599. It is taken as 0.6. Get the point? Options are very far away. 3.5, 7.9, 1.9, 5.6, 6.2. Nowhere close to each other. So I can definitely go for that kind of calculation and get the answer. So 16 by 3 will be how much? 15 by 3 is 5. 16 by 3 will be 5.33. Yes or no? 16 by 3 is 5.33. 5.33 into 0.6. 5 into 0.6. 5 into 0.6. 5 into 0.6 how much? 3. 5 into 0.6 is 3. 5.33 into 0.6 will be more than 3, slightly more than 3. Look at the options. First option 3.5 has to be the answer. Square root of 963 plus 4.895 whole squared minus 9.24 equals to what? The options are 60, 35, 85, 45 and 25. What will be the answer? What's the square root of 963? Square root of 963. Square root of 900 is 30. Square root of 961 is 31. Yes or no? 31 square is 961. So very close to 31. Yes or no? 961 is 31. 963 can be taken as close to 31. 4.895. Can I take it as 5 approximately? 5 square, 25 minus 9.24. Let's take it as 9 or 9.5, whatever it is. 9.24, let's say otherwise. So 31 plus 25 minus 9.24. Find out what is 31 plus 25? 56. 56 minus 9.24. 46, right? 46 point something. Which is the closest one? Fourth option, 45. So the answer here should be fourth option, 45. So this is one set of questions that we have taken, right? Really simple, not complicated. Just try to do an approximate calculation and you'll get the right answer. So follow Bodmer's rule, right? You don't have to neglect that. Follow that rule and we'll be getting the right answers. 6.1 into 24.879 plus 14.059 minus 6 equals to what? What do you do? 24.879, shall we take it as 25 approximately? Yes. Can I take this as 6? Yes. 6 into 25 plus 14.059 is very close to 14 minus 6. Right? This is within the brackets. As per the rules, first simplify the bracketed part. So this becomes 8. 14 minus 6 is 8. Now 6 into 25 plus 8. What is 6 into 25? 150. 150 plus 8. 158 should be the answer. Approximately 158. Look at the options. 110 is ruled out. 190 is ruled out. 220 is ruled out. 98 is ruled out. 160. Close to 158. And here we don't have to worry about two options being close. There's only one option, so directly you can mark that as answer. Right? 3451 divided by 9.895 into 3.0126. 1050, 1235, 900, 1360, 1248 are all not close to each other. So this becomes 3 approximately 3451. Let's keep it as 3451, right? 9.895. Can I take it as 10? Yes, nothing wrong. 9.895 and 10, there's hardly any difference, right? 0.15 is the difference, right? So 3451 divided by 10. 3451 divided by 10 is how much? 345. 345.1, right? So 345 into 3. What is 345 into 3? 340 into 3. 340 into 3, 1020. 5 into 3, 1035. So answer should be close to 1035. Right? This cannot be the answer. 1360 cannot be the answer. 990 maybe. 1235 cannot be the answer. Right? So again, if you look at it, 1035, 990 is close. 45. And how much is this? Just 15. But then now you have to really understand, will the answer be more than 1035 or less than 1035? If it is coming out to be more than 1035, that's the answer. If it is anyway less than 1035, then this will be the answer. Now look at this. We did not change this value. 3451 was 3451 as it is. Yes or no? 3451 was as it is taken as 3451. But then 9.895. Now try to understand. 3451 divided by 9.895. This was approximately taken as 10. Look at this. When we approximately take it as 10, we have got the answer as 345.1 or 345 approximately, right? But the actual denominator is less. Approximate denominator is 10. Actual denominator is less. What happens when the denominator is less? Value will be more. Yes or no? This is very classical mathematics. When the denominator is less, value will be more. Actual denominator is less. That means actual value will be more. When the actual denominator is less, actual value will be more. That means actual answer should be more than 345. Approximately 345 because approximate denominator is 10. But the actual denominator is less than 10. When the actual denominator is less, actual value will be more than 345. This is more than 345. When something more than 345 is multiplied with 3, obviously answer will also be more than 1035. So this 990 gets ruled out. Now I can say 1050 is correct. So that's how we can verify which is correct, the first one or the second one. I mean, it should be more or less. So can I take this as 6,000, close to 6,000, 6,000, 4,800 or 4,900, let's say 4,000. And see, remember, when you're just taking these values, the one thing that you need to keep in mind is, are you taking more values or lesser values? So that when you add the other value, you will accordingly do a change. As I've mentioned, not increase all the values in addition. Increase one, decrease the other. Right? Similarly, in division, increase both or decrease both. Multiplication, do opposite changes. Subtraction, do similar changes. So the point here is 5,995, I've taken 6,000, close to 6,000. But the one point which you need to keep in mind is it's 5 more. So you have, increase the value. Likewise, 4,874, we have taken as 4,900. So 26 more, right? So just keep in mind that you are increasing. Now 3,333. Either you can take it as 3,350 or 3,400 if at all you want to go for that. But then understand, already we have increased the previous two values. So it's better that you decrease this one. So 3,333, if you decrease, can we take it as 3,300? Yes. So this is 3,300 divided by, now a similar case here, 713 and 5, and if you want, you can do the actual addition also. I mean, that's not really difficult. 713 plus 5 not only be 509 will be how much? 1222. 1222 plus 326 will be how much? 1548. So the exact calculation is 1548, right? If at all you're not, you're really good in calculation. So 700, 500, 300. How much is that? 1500. 13 and 9, 22. 20 and 22, 26 is 48. So if you're able to do the proper calculation, better go for it. So this will be how much? 1548. So divide by 1548 equals to what? Now this is the question, right? Now add this one, 6,000 and 4,900. How much is that? 10,900. 10,900 plus 3,300 will be 14,200. Yes or no? 14,200. So 14,200 divided by 1548. 14,200 divided by 1548. Now we are not far away from the exact answer because we have not done too much of approximation. Just 5 more and 26 more. How much? 31 more and 33 reduced. So very close. Are you able to follow? Actual numerator will be 14,202. We have taken 14,200, right? Very close. And this is exact 1548. Now the moment you see this 14,200 divided by 1548, you will know that first option, third option, and fifth options cannot be the answers. Tell me why. 14,200 divided by 1420. Just try to understand. 14,200 divided by 1420. If the denominator is 1420, it will be equal to 10. 14,200 divided by 1420 will be equal to 10. Actual denominator is more. When the denominator is more, value will be less. That means answer should be less than 10. Get the point? If you only look at take the 4 digits, 1420 by 1548. 1420 by 1548. Answer should be less than 1. That means less than 10 when you multiply with 10 there, right? Less than 10. Answer should be less than 10. So 11, 11.5 and 12 gets cancelled. Are you able to follow? If it is 14,200 divided by 1420, I'll get exactly 10. So I'm just trying to compare with this part, this calculation. 14,200 divided by 1420 equals to 10. Here the actual numerator is more. When the actual numerator is more, actual value will be less than 10. Ruled out. Now either 9 or 7.5. At least you're able to cancel out 3 wrong options. Now if you want to take a risk, mark any one of them, 9 or 7.5, or just try to understand. Can it be 7.5? No, we don't think so, right? Can it be 7.5? No, it should be 9. Approximate answer here should be 9. Let me tell you why. Only consider this part, 1420 divided by 1548. Let's take it as into 10. So whatever is this should be multiplied by 10. And if you have understood percentage based calculations, right? Look at this, 1420 by 1548. Find out approximately how much percentage is it. What percentage is 1420 by 1540? Generally we have into 100. Here we have into 10. That's the difference, right? So understand what is the percentage. What do we do in percentage related calculations? We have learned this in speed maths and percentages video as well, right? What do? Always take the denominator as 100%. So what's the denominator here? 1548, 1550. 100% is 1550. What will be 10%? 155. If you really look at the numerator 1420, it's how much? 1550 minus 130 less. Yes or no? 1550 minus 130 will give you 1420. So it's minus 130. That means 1550 minus 130, approximately 1550 minus 130. This is approximately 1550. And this can be taken as 1550 minus 130. So if you understand, this is how much? 100%, because denominator is always 100%. So this is 100% minus approximately. Can you say this is 10%? 155 is 10%. This is less than 155, so less than 10%. So 100% minus 10%, 90%. 90% is what? 0.9. 0.9 into 10 will give you 9. So your answer here is 9. It cannot be 7.5. So this is how you can do such calculations. This is how you can go for approximation when it comes to this kind of a division. Again, may not be possible always to mark the answer. Had the answer been close to 11, we would have been in trouble. Yes or no? We are fortunate that 11, 11.5 and 12 have got cancelled. If the answer is close to 11, then it becomes difficult. It can be 11, it may be 11.5, and maybe 12 also. Right? So it all depends on what options are given to you. Right? I would say if at all you find the answer is close to 11, better leave it. Don't take a chance, because 3 are possible. The only way to do it is do the complete calculation. I mean, try to do a very precise calculation in that case, or try to do it on paper. Maybe then you'll be able to find out the exact answer. 0.8% of 384 into 0.9% of 362. So that's like percentages you have to find out approximately and multiply them. What is 0.8% of 384? 0.8% is how much? I am not going to write anything on paper this time, right? It's all oral calculation, mental calculation. You must be able to do this, and it's all based on simplifications, right? Nothing really to do with much to do with approximations. 1% of 384 is 3.84. 3.84. 1% is 3.84. 0.8% is 1% minus 0.2%. 0.1% of 384 will be 0.384. So 0.2% will be double of that, right? 0.76. 0.76. So 0.8%, that is 1% minus 0.2%. So 3.84 minus 0.76, approximately 3.08. This is close to 3.08. Please do not misunderstand that I have memorized the answer. I'm just trying to speak it out. No, I'm trying to do the approximate calculation on the spot. If I can do this, even you can do that. But what requires here is practice, and more practice. Right? Then 0.9 into 362. 0.9% of 362. Again, 0.9% is 1% minus 0.1%. What is 1% of 362? 3.62. 0.1%, 0.362. So 3.62 minus 0.362 will be how much? 3.24. Approximately 3.24. Like 3.6 minus 0.36. 3.24. That's it. 3.08 into 3.24. 3 into 3 is 9. 0.8 into 3, 0.24 into 3. So 0.32 into 3. 0.32 into 3 is 0.96. So 3 into 3, 9. 0.8 into 3 plus 0.24 into 3 is 0.96. 9.96 plus 0.08 into 0.24. As I've mentioned, that can be neglected. So 9.96, close to that. 9.96, 10. Though all are close again. I mean, if you really understand 11, I mean 12, 10, 8 seems to be close. But then you must be able to mark 10 as the answer without any difficulty, right? So third option, 10 can be taken as the correct.